Hello, and welcome to the stream. Today, we are going to try something new. And instead of playing a game like Survive the Night or a new game, depending on if I have something in my library that I haven't tried yet and I want to, we're going to try and include a coding day each week. Friday feels like a good day to do that, kind of like a break from everything. And because I absolutely love games, I've always wanted to get into game development. And Quellis Dev has introduced me to Godot. I thought I'd go ahead and give it a shot and try it out and see what it's like. And so I thought, hey, why don't we go ahead and just go through the tutorial together and check out the docs and, kind of work through it. I learn it, you learn it, we all have a good time, hopefully. So I'm going to go ahead and change my monitor. Here we go. So here I'm at the go.engine.org docs. Last night I went ahead and downloaded the Godot zip file. You can go straight to their website. Let me see. Let me just go ahead and show you all this stuff. You can go here and then you can just download the latest. This is available for both a Mac and Windows. It didn't actually need to be installed or anything like that. So as soon as I unzipped it, I double-clicked the executable and it was available immediately. This is the Godot Engine UI that we're going to be working with. And the documentation is actually not that bad. If you walk through the introduction, it's kind of geared a little bit more towards beginner programmers, people that have never done any programming before, but they do talk about experienced programmers as well, can pick this up pretty easily. Godot does support C# for those that have been in the game industry quite a while and have experience in C#. I myself do not have experience in C# and haven't had the opportunity to learn it yet. So I'm just going to go ahead and learn the GD script, which is the Godot language, pretty much. So as you go through the Godot, the instructions here in the docs, it kind of walks through how the UI works, then kind of goes through some of the main features in the step-by-steps, like how they describe the structure of your programs in the games and things like that. When you create a project, you have the ability to do a 2D or 3D, depending on the type of nodes you create. And the way that they structure it is nodes are the smallest element within the structure of your game, pretty much. So you have nodes which make up scenes, and then scenes make up bigger scenes, I guess. A scene is a tree of nodes. So, for instance, let's see. Let me grab an example real quick. So right here, this is a scene, which is a character. And it takes 3 nodes that are underneath it as a tree. So it's a sprite, which is the image. It has a collision shape to it, which is a square. And then sorry, stumbling over my words. This image right here, this character, will also have a 2D camera that'll be fixed on it. So this is now a character scene. And so what happens here is that then you can create another scene, for instance, main, which would most likely be the main scene of the game. And you would add this player in. You would instantiate this player character. And then if you needed a enemy character, for instance, then you could create that. Or let's say you wanted to do a multiplayer, you could do a player 2. You would instantiate the second character in here as well as an option. So there's different ways to do that. And then let's see, setting the main scene. There's a few that's using signals. I kind of want to show real quickly structure. Sorry, I went through this pretty quickly last night. All right, here it is. So, scene instances as a design language. So, they wanted to try to make it intuitive. And in Godot, they specifically said, we recommend dismissing architectural code patterns when making games with Godot, such as model view controller or entity relationship diagrams. So, trying to gear away from normal programming patterns that we have done for like setting up a website or microservices and things like that. Instead, you can start imagining the elements players will see in your game and structure your code around them. So, for example, let's say you have a single stage, right, in a shooter game. You're gonna you want to structure it kind of like looking at, all right, you're gonna have weapons. You're going to have a player ship. You're going to have an enemy. You're going to have obstacles. You're going to have HUDs, which will include markets, enemies, and missiles. So this structure kind of is a little difficult to follow along. I like this one. It kind of makes a little bit more sense. So this is an example that they showed for a scene diagram for an open world game. So when you're looking at an open world game, it's like, what are the elements within an open world game? So in this one, you have the main terrain, the open worldness. In this specific example, you have your player, which then also has an HUD. So the player owns the HUD, the terrain owns the player. Oh, no, sorry. The arrows mean it's owned by. So the player owns the HUD. And then since the terrain doesn't have an arrow around the HUD, then the player just exists within the terrain. The terrain owns a bridge. So a bridge exists. Guards are on the bridge. So there's guards and bridges on the terrain. There's a citadel. And within the citadel, there is a church, and then there are seats. There are also houses. And within the house, there are rooms, doors, tables, chairs, and a vases or vase. So as they were explaining here in this part, as you're developing, you can go through and say, well, I'm just going to work on a room. Well, I can make multiple different types of rooms. So you start with your base room as, your base room. And then from there, you instantiate different rooms with different structures to it of furniture and move them around, structure them a little differently. They follow a lot of inheritance around this. So you could have like a base room, and then you want to expand it to have a couple more features to it. Then that would inherit from the base. So if you change anything on the base, it would automatically update the child. But that's how they kind of suggest structuring Godot games and the file system, essentially. Look at everything as elements, and each element is a scene, and each scene can be instantiated different ways. So I kind of like that approach. But I need to kind of get into it to really get used to it and see what it's like. So I'm going to actually minimize my webcam a little bit more, just so if you wanted to read ahead. Yeah, let's move me right there. Sorry, my Brave stuff keeps popping up. So I'll just go ahead and we're going to start with the first 2D game. And if you want to read ahead of me, you're more than welcome to. But we're going to go through this pretty slowly just to get started. So first things first, let's create a new project. This thing is supported of Forward Plus as a render. Let's see, supports desktop platforms only. Advanced 3D graphics available, can scale to large complex scenes. Uses rendering device backend and slower rendering of simple scenes. Mobile supports desktop and mobile platforms. So if I wanted to make a mobile game, this is the selection I would want to use. And compatibility allows you to also make web platforms. So that's pretty cool. So let's go ahead and move this. I don't want things in my OneDrive at all. Um, so let's go here. Where did I have it? I think yeah, thought I had a folder in there. Okay, maybe I did not. Uh, tell OneDrive there. Huh? Okay, let's create a new folder here. Here it is. Get that there, and we're gonna select the current project folder, and we're gonna name this first 2D game. Create and edit. So now it opens up. All right, so it automatically, actually, let's go full screen for a moment so we can just kind of look at the UI a little bit. So we have our 3D vectors, Z, X, and Y. So the red is X, the same blue Z, and Y is up and down. Then on 2D, you got X and Y. This right here would be the window screen. So if I decided to put anything in here, so let's just go ahead and do an example. Let's go. This is an example that I saw that I went through for the instruction. So we'll do a label. Let's create that. And then from here, we'll edit the properties and say hello world, because that's what you normally do. Select that and move it here. I want to transform it, so make it larger. Sorry, that's a little too big. All right. Trying to learn the shortcut keys too. So now I have that. So let's go ahead and save this as label. Save that there. And now this is the run the project. So F5 means that you'll just run what you're selected on. F6 will also do that, but I believe it's a different way of doing it. Hey, Diggs, BTW, how you doing? Welcome to the stream. So this is the debug. It automatically runs the scene. And so now we have hello world. So if I move this over here and run it again, you'll see that the text also moves. So that is essentially how it works. So this would be a scene node, or sorry, a scene using a single node. So we don't actually need this, so I can delete that. Don't save. So now we go back to an empty, and let's go ahead and get to the actual docs and go step by step and see how this works. Daddy, hey dishwasher, how you doing? Is this game going to have feet? This is the example of the game actually that we're going to try to create. So it kind of has feet, little stubby feet. So Let's see. In the step-by-step tutorial series, you will create your first complete 2D game with Godot. By the end of the series, you will have a simple yet complete game of your own, like the image below. Lol, we take those. Yeah, maybe we should set up an OF for this little guy. You will learn how Godot editors work, how to structure a project, and build a 2D game. Note: this project is an introduction to the Godot engine. It assumes that you have some programming experience already. If you're new to programming entirely, you should start here with the scripting languages. That's fine. Oh, I should also mention, when I was going through the introduction, I did see that it allows you to do some programming in C++, and you don't have to recompile it, which is actually kind of cool. So that's pretty neat. And I may have read that wrong. That it may have, there's a little bit of uniqueness around that. So let's see. The game is called Dodge the Creeps. Your character must move and avoid the enemies for as long as possible. Fast as lightning. This language fugs. We'll see. We'll see. I mean, some of the examples when I was going through the introduction stuff does seem like they pulled some inspiration from like JavaScript. So maybe we'll see. Go away, Brave. All right. So we're going to create a complete 2D game with the Godot editor, structure a simple game project, move the player character and change its sprite, spawn random enemies, and count the score. And more. Okay. You'll find another series where you'll create a similar game, but in 3D. We recommend you start with this one, though. Why start with 2D? Well, it's 1D less, of course. If you are new to game development or unfamiliar with Godot, we recommend starting with 2D. This will allow you to become comfortable with both before tackling 3D games, which tend to be more complicated. You can find a completed version of this project at this location. And then here's the GitHub to pull it down. Prereqs, go through the tutorials and do the get started. Blah. If you're an experienced programmer, you can find the completed demo code here. Yeah, don't want to look at that because we want to start from scratch. We prepared some game assets you'll need to download so we can jump straight to the code. You can download them by clicking on the link here. So we extracted that. Let's go set up the project. So we did that. Launch Godot, create the project. All right, when creating the new project, you only need to choose a valid project path. You can leave the other default settings alone. Okay. Okay, we did download the Creep 2D assets. The archive contains the images and sounds you'll be using to make the game. Extract the archive and move the art and fonts directory to your project's directory, which I did. So if we open that here, we have arts and fonts. Yeah, we can restructure. All right, let's just restructure it like this. Let's move arts and fonts directly here, and then we'll just go ahead and delete that. Okay, so now we have arts and we have fonts. All right, your project should look like that. All right, and that is what we have. Excuse me, got a call. All right, this game is designed for portrait mode. So we need to adjust the size of the game window. So we want to click on project, project settings to open the project settings. In the left column, open the display window tab. So display window. Here, set the viewport width to 480 and height 720. All right, so width, we're going 480, height 720. Oh, I like it. You can hover, I guess. I'll tell you about it. Yeah, that's good. That's nice. All right, so we did that. Also, under the stretch option, set mode to canvas items and aspect to keep. This ensures that the game scales consistently on different sized screens. All right, so we go down to stretch. Let's see. Set mode to canvas items and aspect to keep. It's on keep, so we're good there. All right, so now we close. In this project, we will make 3 independent scenes: player, mob, and HUD, which we will combine into the game's main scene. In a larger project, it might be useful to create folders to hold the various scenes in their scripts. But for this relatively small game, you can save your scenes and scripts in the project's root folder, identified as res, as in resource. You can see your project folders here, right there. With the projects in place, we're ready to design the player's scene in the next lesson. Then we have your user contributed notes, which I am going to skip over. Portrait mode not in the picture. This is a change that was made in 4.3. Okay, skip that. Okay, creating the player scene with the oh, by the way, if you notice, this Windows is now a lot smaller and matches what we did for the change. So just wanted to show that. Let's see. The first scene will define the player object. One of the benefits of creating separate player scene is that we can test it separately even before we've created other parts of the game. All right. I like that. It's like unit testing. To begin, we need to choose a root node for the player object. As a general rule, a scene's root node should reflect the object's desired functionality, what the object is. Click the other node button and add an Area 2D node to the scene. All right, so let's look at what an Area 2D is. An Area 2D node is a region of 2D space that detects other collision object 2Ds entering or exiting it. Okay. Okay, configuration warning. This node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. All right, so pretty much this is just saying that this is a 2D thing in the space of the game. All right, Godot will display a warning icon next to the node in the scene tree. You can ignore it for now. We will address it later. With Area 2D, we can detect objects that overlap or run into the player. Change the node's name to player by double-clicking on it, and now that we've set the scene's root node, we can add additional nodes to give it more functionality. All right, so we'll name this player, like it says. All right, before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. Select the node and click the icon to the right of the lock. Its tooltip says groups the selected node with its children. This causes the parent to be selected when any child node is clicked in 2D and 3D view. So that thing? Group selected node. Oh, okay. I guess we'll see what that actually means later. Save the scene. All right, we save it. Save. And now we have player TSCN right here. For this project, we will be following the Godot naming conventions. GD script. Classes, nodes use Pascal case. Variables and functions use snake case, and constants use all caps. Oh, not all caps. I hate all caps. That's screaming snake case is what that is. Damn you, Godot. All right, classes is Pascal, snake case, variables and functions. Constants are all caps. Wow. Okay. Skip the C sharp. We're not doing C sharp. All right. Click on the player node and add Control A, a child node. The animated sprite. Okay. Or we can click this button right here. Attach a new or existing script to the node. Nope. Sorry. That's the script. Is it this one? Add child node. Yep. So I have this highlighted. I click that. Then we can type that in. Animated 2D sprite right there. Sprite node that contains multiple textures as frames to play for animation. Okay, so that gets added. The animated sprite 2D will handle the appearance and animations for our player. Notice that there is a warning symbol next to the node. An animated sprite 2D requires sprite frames resource, which is a list of the animations it can display. To create one, find the sprite frames property under the animation tab in the inspector and click empty, new sprite frames. Click on the sprite frames you just created to open the sprite frames panel. Okay, so animated. This is the inspector. We want to go to, what does it say? Property under animation. Where's animation? Oh, right here. Animation. Go to sprite frames. New sprite frames. Click on the sprite frames. Is this it? Oh, then I click on that and then pulls up the resources. Uh, what? Hmm. Oh, it's down here. Okay. Animation sprite forms down here. Okay. So we're down here in the sprite frames panels. Yeah. All right. Still getting used to the UI. This is brand new to me, y'all. All right. On the list. Oh, sorry. Got a cough. All right. On the left is a list of animations. Click the default one and rename it to walk. Walk. And then click the add animation button to create a second animation named up. Add animation. Okay. Up. Find the player images in the File Systems tab. All right. All right, here's that. They're in the art folder you unzipped earlier. Drag the two images for each animation named Player Gray 1 of 2, Player Gray Walk 1 of 2 into the frames, animation frame side of the panel for the corresponding. Okay, so this is up. I'm on. So that goes there. And this is walk. So that goes there. Okay. The player images are a bit too large for the game window, so we need to scale them down. Click on the animated sprite node. This one. Good. No, nope. this one. Yeah. Okay, the player images are a bit too large for the game window, so we need to scale them down. Click on the animated sprite, okay, that node, and set the scale property to 0.5 and 0.5. Scale. Right, 0.5. All right, so that lock button means that it'll keep the scale together. So if I change this X, then Y changes with it. If I click that and change one, it won't change the other. So that's nice. You can find it in the inspector under the Node 2D heading. All right. Finally, add a collision shape as a child of player. Oh, I should probably add the second things to these. So add that one there. And then we're going to add that one there. They need an all collapse button. All collapse and all uncollapse. Finally, add a collision shape 2D as a child of player. This will determine the player's hitbox or the bounds of its collision area. For this character, a capsule shape node gives the best fit. So next to the shape in the inspector, click empty, new capsule shape 2D. Using the two size handles, resize the shape to cover the sprite. Ooh. Sorry, bug. I had a bug show up in my room. All right, collision 2D shape. Okay, so then we go over to shape and capsule shape 2D. Okay, and we want to resize it. Let's zoom in a little bit. Let's open that up. Go like that. Too big. Right there. There. Hmm. Let's see. Can I get that to be like as close as possible? I think that's the best. Yeah. I do that. I think it's pretty close. Yeah. Okay. We'll go with that. That's pretty close. Kind of want to move it to the center of the window so I can look at it easier. I'm using the scroll wheel to zoom in and out. Yeah, I think that's good enough. All right. When you're finished, your player scene. Sorry. When you're finished, your player scene should look like this. Okay, it does. I can hide that. Okay, that's cool. Make sure to save the scene again after these changes. In the next part, we'll add a script to the player mode node to move and animate it. Then we'll set up the collision detection to know when the player got hit by something. Okay, let's go ahead and save it. All right, move to the next. All right, in this lesson, we'll add player movement, animation, and set it up to detect collisions. To do so, we need to add some functionality that we can't get from a built-in node. We'll add a script. Click the player node and click Attach Script button. All right. In the script's settings window, you can leave the default settings alone. Just click Create. If you're creating C# or another language, do something else. Let's just see. Okay, only those two languages. Player GD. Nice. Template mode. All right. Inherits from the area 2D. So we create that. All right, so we have function ready. Oh, it does feel a little like Pythonic, I guess. Unused parameters. That must be delta. Okay, what do we got here? If this is your first time encountering GD script, please read the scripting languages before continuing. Start by declaring the member variables this object will need. So, var screen size. Okay, so we're doing global variables. So we want to export var speed equals 400. Okay, and then var screen size. All right, so let's go ahead and add these comments as well, just so we have it, how fast the player will move. That's pixels per second. And this is size of the game window. All right. This must get passed into us in some form or fashion. So this speed starts off at 400. Or maybe it's just a constant set at 400. And we export it out. Which should mean that if we have other functions in other scripts, they should have access to that variable. Yeah, sorry. I'm probably about to read that. Using the export keyword on the first variable speed allows us to set its value in the inspector. Oh, that's what that means. Interesting. Okay. This can be handy for values that you want to be able to adjust, just like a node's built-in properties. Click on the player node and you'll see the property now appears in the inspector in a new section with the name of the script. Remember, if you change the value here, it will override the value written in the script. So here in the inspector player, so if we change this to 300, it overrides this. Okay. Cool. Overrides it, but doesn't like change it within the actual script itself. If you're using ReSharp, you have to hit the build button. All right. Your player.gd script should already contain ready and process. If you don't select the default template shown above, create these functions while following the lesson. The ready function is called when a node enters the scene tree, which is a good time to find the size of the game window. Okay. So let's go ahead and do that. So we can size. I like the autocomplete. Get viewport rectangle dot size. Okay. Called when the node enters the scene tree for the first time. So this is upon instantiation within the scene. Called every frame. Delta is the elapsed time since the previous frame. Okay. So let's assume 60 frames per second. So every 1/60th of a second would be the delta. So each frame is 1/60th of a second. So if you're moving, we would use that delta to calculate on the screen itself where on the screen you would move 1/60th of that within that time. especially at a speed of 400. Okay. All right. Now we can use the process function to define the player, what the player will do. Process is called every frame, so we'll use it to update elements of our game, which we expect will change often. For the player, we need to do the following: check for input, move in the given direction, play the appropriate animation. First, we need to check for input. Is the player pressing a key? For this game, we have 4 direction inputs to check. Input actions are defined in the project settings under Input Map. Here you can define custom events and assign different keys, mouse events, or other inputs to them. For this game, we will map the arrow keys to the 4 directions. Click on Project Settings to open the Project Settings window and click on the Input Map tab at the top. Type Move Right in the top bar and click the Add button to add the Move Right. It's Project Settings. And then we want Input Map. Oh, at the top. Okay, that tab. And then we want to add a new action. So move right, add, do that. Let's say keyboard keys. Just right. Physical keyboard position on US QWERTY keyboard. All right. I'm just assuming that that's what's going to happen next. All right, we need to assign that. Press the plus button to open the event manager. The listen for input field should automatically be selected. Press the right key on your keyboard, and the menu should look like this now. Okay, so let's change that again. So that. All right. Just make sure that that's correct. Select OK. The right key is now associated with move right. Repeat these steps for the rest. Move left. Move up, down. Move left. Up. And move down. Um, I would love. I'm really hoping that there is a tutorial out there with how to do touchscreen controls. Because if you want to do a mobile apps, like you're gonna want to use touchscreen controls. So, actually, let's just kind of look at that. Move up, touch screen. Keyboard, mouse, keyboard, joypad? No. Okay, I'm gonna have to look into that. See how to do that. So now our input looks like that. Now we can close the project settings. You know what? Where did I... Let's go back. I actually want to add more. This is move right. We're going to do D. Left is A. Move up is W. Move down is S. Gotta have that AWSD in there. You can detect whether a key is pressed using input.isActionPressed, which returns true if it's pressed or false if it isn't. All right. So, for default value, our velocity is to vector 2.0. The player's movement vector. Okay. That is action rest. Oh yeah, uses that. Just gonna do this real quick because it's faster. Yeah, this is white space focused. So let's say move. Let's keep it the same as the tutorial. So move right, move left. This is move down. Move up. All right, so what do we do here? We take the velocity, take the x value, because that's left to right, and we're going to add 1 to it. So plus equal takes the original value of velocity, and this is essentially shorthand for velocity.x is equal to velocity.x plus 1. So we're going to copy that. Here we're going to say minus 1. And then these are going to be the y direction. So that's y. Y. That'll be... Oh, down is positive and up is negative. Interesting. Wonder why that is. Wonder if that's a misprint. So that gives us our velocity. So length is greater than 0. What are we going to do? Take the velocity, and we're going to take it and normalize it. And we're also going to multiply it by the speed, so we have know how fast we're going. And then I don't know what this is. Animated sprite.2d. Oh, it's saying to play the sprite animation. If we're not moving, then we need to stop the animation. Okay. So we haven't actually moved the character yet. We've identified that we are moving by the action pressed, and we have told the sprite animation to play if we have pressed a button. We didn't say which one though. Okay. You start by setting the velocity to 0, 0. By default, the player should not be moving. Then we check each input and add or subtract from the velocity to obtain a total direction. For example, if you hold the right and down button at the same time, the resulting velocity vector will be 1, 1. In this case, since we're adding a horizontal and vertical movement, the player would move faster diagonally than if it just moved horizontally. If we can prevent that, if we normalize the velocity, which means we set its length to 1, then multiply by the desired speed. This means no more fast diagonal movement. If you've never used vector math before or need a refresher, you can see an explanation of vector usage in Godot at Vector Math. It's good to know, but won't be necessary for the rest of this tutorial. Okay. We also check whether the player is moving so we can call play or stop on the animated sprite 2D. The money sign is shorthand for get node. So in the code above, money sign animated sprite 2D dot play is the same as get node. Pass in the name of the node, play. In GD script, money sign returns the node at the relative path from the current node, or returns null if the node is not found. Since animated 2D is a child of the current node, we can use that shorthand. Okay. Now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Clamping a value means restricting it to a given range. Add the following to the bottom of the process function to make sure it's not indented under the else. Obviously. So we do position. Did we have position defined already? Process input. No. So position is a new value. Interesting that we didn't have to define it. Let's see, vector 20 screen size. All right. What is this actually doing? So we're taking the velocity, which is really just the position. Yeah, the movement of the sprite. So, as the example again, right and down would move it 1 and 1, and delta would multiply it in for the single frames, like a portion of that in that diagonal direction. And so the position would tell us exactly like where that is. And then we're clamping it, saying that this position needs to be within 0, 0 and the screen size. I don't see how this could be bigger. How could this position ever be bigger? Is that because... Oh, okay. I get it. Position is a variable within the inspector. That's why it's already predefined. So it already has an XY value, and we're multiplying this. So it's grabbing the XY value, and we're adding the velocity and delta to it. Or, sorry, velocity times the delta to it. And then we're checking to make sure that we are still within the position, within the screen size. Okay. The delta parameter in the process function refers to the frame length, the amount of time that the previous frame took to complete. Using this value ensures that your movement will remain consistent even if the frame rate changes. Click Run Current Scene, F6, and confirm that you can move the player around the screen in all directions. If you get an error in the debugger panel that says attempt to call function play in base null instance on the null instance, this likely means you spelled the name of the animated sprite 2D node wrong. Node names are case sensitive, and node name must match the node name in the scene tree. Well, it auto completed for me, so So we have to save first, get that highlighted, and then we're going to hit F6. We are moving. We move. And we can go diagonal. Okay, that's kind of cool. Now the animation does the walking, but it is, let's see. No, that's not it. Where is the art? Animated sprite here. So the walk, so the up down is working. The left right is does not appear to be. Does not appear to be it. So if I do that, say F6 again. Okay. All right. Cool, 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 cool. All right. Now we're going to do the choosing animation. Interesting. Now that the player can move, we need to change which animation the animated sprite 2D is playing based on its direction. We have the walk animation, which shows the player walking to the right. This animation should be flipped horizontally using the flip H property for left movement. We also have the up animation, which should be flipped vertically with flip V. For downward movement, let's place the code at the end of process. Okay. All right, all right, all right, all right. So we're at the end of process. We have updated the position. So if the velocity does not equal 0, say the animated sprite animation is equal to walk. Okay, so that changes this right here from walk to up, or from up to walk and so forth. Animated sprite dot flip v is equal to false. Okay, so flip v is for downward, so v and h. Flip vertically. Trying to understand. So that's left and right. So flipping vertically means flipping like this. Flipping horizontally means flipping like this. Okay. So if we're walking left and right, we don't need to flip vertically. So here, yeah, let's write that flip h velocity. This is only true if that is less than 0. Okay. So we're using this to as a boolean. So we are using the walk animation, and we're flipping across the h if this is negative, which is defined up here. Okay. Elif. Right, we're going to do it now for the up down. So the logic is pretty much the exact same. So let's just copy and paste it because it's faster. Oop. All right, so we want this to be up. And this velocity.y is less than 0. Is that correct? Yeah, I think that's correct. And then this will be false. I wonder why they didn't do that here. Is it necessary? Let's see. Let's check the note first. The Boolean assignments in the code above are common shorthand for programmers since we're doing a comparison test, Boolean, and also assigning a Boolean value. We can do both at the same time. Consider this code versus the one line Boolean assignment above. Wait. Oh, wait. That's what? Okay. Flip V is false. Oh, we don't ever want to flip horizontally. Right? No. Wait. I'm confused. Horizontally. Hmm. Hmm. That's no. The example's not here. Okay. I don't. Okay. I am not 100% certain about this. So let's remove this because I don't fully grasp why it's flip H and flip V. Okay. This animation should be flipped horizontally using the flip H property for left and right movement. Okay, that makes sense. We also have the up animation, which should be flipped vertically. Okay. Yeah. So why wouldn't we flip the... Why would we not horizontal? I guess I'm just thinking it oddly. So we're flipping it vertically versus horizontally. But I'm thinking it as flipping over an axis. I guess that's what's confusing me. Oh, let's just go with it. Play the scene again, check the animation is working. All right, let's save it and run it. Okay, so it flipped it up, down, left, right. Wait, if those are the feet, right? Up, down. That doesn't feel right. I would want the feet to be behind me. Wouldn't you? Wouldn't you want the feet to be behind you? Would the feet be up above you? Okay. All right, so let's see how we would change that. Let's say that. Save that and run that. Okay, so I just reversed it. All right, so I guess the reason they did that is so that we don't diagonal does the walking and keeps it upright at all times. Up, down. Yeah, to me that makes more sense the way it looks. Because you're looking up, now you're looking down. Oh, I wrote it backwards. Okay. So I was incorrect. It did look wrong. That's what I get for skimming. Not really paying attention. All right. When you're sure the movement is working, add this line to underscore ready so the player will be hidden when the game starts. Okay. Hide. Right. Now we got to prepare for collisions. Wow, this is kind of involved for just a 2D simple game. But I still kind of like it. All right, we want the player to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay because we're going to use Godot's signal functionality to make it work. Add the following at the top of the script. If you're using GD script, add it after extends area 2D. If you're using C sharp, add it after public partial class, blah, 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 blah. All right. Extends area 2D. So here, signal hit. This defines a custom signal called hit that we will have our player emit, send out when it collides with an enemy. We will use area 2D to detect the collision. Select the player node and click the node tab next to the inspector tab to see the list of signals the player can emit. Node. There. Hit. There it is. Okay, notice our custom hit signal is there as well. Since our enemies are going to be rigid body 2D nodes, we want the body entered body node 2D signal. This signal will be emitted when a body contacts the player. Sorry, need to readjust. Back's kind of hurting. Click connect, and the connect signal window appears. Godot will create a function with that exact name directly in the script for you. You don't need to change the default settings right now. Warning, if you're using an external text editor, for example, Visual Studio's Code, a bug currently prevents Godot from doing so. You'll be sent to your external editor, but no new function won't be there. In this case, you'll just need to write the function yourself. Okay. So body entered, and then we hit just connect. Oh, here it is. Connect. Connecting from player. Yes. On body entered. So we're saying when another object enters the collision zone of the player. So that's the signal we're looking at. So now if we look at where is it? Oh, here it is. On body entered right here. And by the way, returns a void, meaning that there is no return value. All right, so that's all there. Note the green icon indicates that a signal is connected to this function. This does not mean the function exists, only that the signal will attempt to connect to a function with that name. So double check that the spelling of the function matches exactly. Next, add the code to the function. So on body entered, on body entered. Yep. So we want the player to disappear immediately. So player disappears after being hit. Hit.emit I'm not sure what that one does, but we'll find out. Must be deferred. So we can't change physics properties. Physics callback. We're gonna have to read what that means. Okay, so on the collision, set deferred disabled to true. Yeah. Each time an enemy hits the player, the signal is going to be emitted. Oh, okay. So this is hit.emit actually sends the signal. We need to disable the player's collision so that we don't trigger the hit signal more than once. Okay. But why is it deferred? Disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing. Using set defer tells Godot to wait to disable the shape until it's safe to do so. Alright, so this means most likely that it's a sequential thing. So as the sprite gets hit in the collision, we emit the signal. So the code will execute the hide, so the sprite disappears, emits the signal, which then hits the set deferred, but the process is still running whatever the signal is doing. And then once that completes, then it defers back and disables the collision. Okay. Unless the signal is running as a separate function. And what this is saying is that we're setting this disable of the collision to deferred, which means that occurs. The collision shape is disabled once this function completes, which is most likely what it is instead. All right, the last piece is to add a function we can call to reset the player when start a new game. All right, so function start. Func start pause for position. Position is equal to pause. And then we're going to show the character, and collision shape.disabled is equal to false. With the player working, we'll work on the enemy in the next lesson. Okay, let's go ahead and save it. Like, you would like to see the image flip vertically when moving down. Well, diagonally, I change it like this. Okay. Cool. Could always play around. Add some lines to yours. Now the sprite also rotates diagonally. That dude went ham on this thing. Let's move on. So we're only on step 4, and there are 3 more steps to get through. So now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edge of the screen, choose a random direction, and move in a straight line. We'll create a mob scene, which we can then instantiate to create any number of independent mobs in the game. So now we want to create a new scene. So click New Scene. Then we're going to do this, and we're going to do a rigid bodied 2D. All right. Let's go ahead, and then we're going to name it mob Let's go ahead and add the animated sprite. We want to add the collision shape. Oop, that goes there. And then we want to add the visible on-screen enabler, which we will find out what that does. Don't forget to set the children so they can't be selected. So this, what was it over here? What was that button? I already forgot where that button was. Anybody remember? If you're still in the chat. What was that button that I was looking for that links it? Oh, I don't want to go back. I don't want to go back. I'm going to go back. Uh, oh, I need to get out of this. Saved. How do I close this? Instantiate child scenes? No. Um, I don't want this to be open. Close. That to be open. I don't want to be in a script view. A Now I'm all confused. Let's just go ahead and save this as mob. Okay. Because that, I can't even get back to the player scene. How do you get out of this view? Detach script. No. Collapse. Editor. Okay. I am a little confused. Why is the script view stuck open? Oh, duh, because I'm on the tab script view. Okay, so then I hit this and I'm back. Okay. That's better. Let's go back so I can actually see it. All right, so like this is how I get between it. And then here's the asset library. If I need to pull some stuff from the asset libraries from online. So that's all right. All right. All right. All right. I got that now. So then I go here, do that, and click that. All right. Now we're good. Select the mob, and then we want to set its gravity scale under collision. No. Select the mob node and set its gravity scale property in the rigid body 2D section of the inspector to 0. This will prevent the mob from falling downwards. Mass gravity scale 0. Okay. In addition, under the collision object 2D section just beneath, expand the collision group and uncheck 1. Wait, under mob. Oh, that one. Expand the collision group and uncheck the 1 inside mass property. This will ensure the mobs do not collide with each other. Okay. Set up the animated 2D like you did for the player. This time we have 3 animations: fly, swim, and walk. Oh, my phone is going off. Let me go ahead and put that on mute. Project settings. Nope. Sorry. That's not what we did. Animated sprite script. Yep, that's what that was. And then we went to animation, new sprite frames. Went to animation. Resources. Okay. And then we call this fly. This one will be swim. And then we want walk. So let's go grab, all right, flying 1 and 2. Swim 1 and 2. And walk 1 and 2. All right. And then we probably have to scale this down again. Transform, scale 0.5. Let's go back to the animated sprites. Let's see. You can use, let's see, set up the fly, swim, and walk. There are 2 images of each animation in the art folder. The animation speed property has to be set for each individual animation. Adjust it to 3 for all 3 animations. So 3 FPS. 3 and 3. Just verifying. Okay. You can use the play animation on the right of the animation. This one. Oh, there it is. Oh, you're cute. Okay. Pause it. We'll select one of these animations randomly so that the mobs will have some variety. Like the player images, these mobs' images need to be scaled down. Set the image scale to 0.75. Oh. All right, let's go back and change the scale back to 1. Okay, so animated sprite. Transform scale to 0.75. All right. And now we got to do the capsule. To align the, as in the player scene, add a capsule shape for the collision. To align the shape with the image, you'll need to set the rotation property to 90 under transform. Okay, so we want a capsule shape, transform it, rotation 90. Now we're going to go in, and we need to make it bigger. That. here's the question. Does that all... The fly is a little bit smaller. Fly animation's a little smaller. Oh well. Don't get hit by the fly. Anticipate. Okay, now we're going to add a script to the mob. Add a script to the mob like this. Okay, rigid body 2. All right, so now let's look, extends rigid body 2. Yep. Now let's look at the rest of the script in ready. We play the animation, randomly choose one of the 3 animations. Okay. So of our mod types. So here, animated sprite.2d sprite frames dot get animation names. Okay, so that is there. That doesn't tell me what that actually is. If I had to guess, get animation names returns an array of names. So mob types would be an array of all the animation names. So it would be sprite frames get animation names. Yeah, so that'll be swim, fly, or walk. So here, now we take the animated sprite and then we're going to play one of them. Mob types using random. And we're going to mod it by the mob types.size. So basically 3. So we're going to take a random number and mod it by 3. So your value becomes 0, 1, 2. Which then means that the animated sprite 2D will then pick one of those values. Yeah, okay. It literally just goes into that. First, we get the list of animation names from the sprite's frames property. This returns an array containing all 3 names, walk, swim, fly. We then need to pick a random number between 0 and 2 and select one of these names from the list of array. Indices start at 0. Randy mod n selects a random integer between 0 and n minus 1. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal of the visible on-screen notifier 2D node to the mob and add this code. On the last piece, is to make the mobs delete themselves when they leave the screen. Collect the screen exited signal node of this. Screen exited? This one? Uh, wait, what? Invisible. Body exited. The last piece is to make the mobs delete themselves when they leave the screen. Connect the screen exited signal to the mob. Shape what? What the hell is Godot? Is that Go if banged.net? Possibly. um, this has me going. Connect the screen. I know you just explained how to do this in the previous section, but maybe you could give a little more context. Like, what is queue free? Answering my own question here. Maybe this was given in a previous section of the getting started. Free, the node is not deleted instantly, and it can still be accessed before deletion. It is also safe to call queue free multiple times. Use object.queued for deletion to check if the node will be deleted at the end of the frame. Note, the node will be freed after all other deferred calls are finished. Using the method is not always the same as calling object free through object.callDeferred. Ew. This part confused me too. For people like me taking breaks between sections, screen exited is a signal built into the visible on-screen notifier node. Select visible screen notifier 2D in the screen tree, then click the node tab next to the inspector. Then you'll find the screen exited signal. Right-click and select connect and connect it to your mob node. Okay. So I was on... That's what I meant. So we have to do that. All right. Okay. I screwed that up. Okay. All right. Cool. So then right here, queue free. So visible on screen. When it's no longer on screen, then we do the queue free, which according to this documentation, the node is not deleted instantly. Use an object is queued for deletion to check if the node will be deleted at the end of the frame. So if you wanted to access a node that could possibly be deleted, you have to do that. Hey, yo, Greg's. How's live coding going? I mean, it's fine. There's a ton of people like watching me, so not terrible. I'm just reading through the documentation and trying out their getting started stuff. It's like we're sitting together in the bullpen again. Just a bit, except you're not next to me where I can ask you questions, making you want to work from home. Use object queued for deletion to check if the node will be deleted. No, the node will only be freed. Okay, so queue free means that it's going to queue up the node to be deleted. And it'll happen at the end of everything. The node will only be freed after all other deferred calls are finished. Using the method is not always the same as calling object freed. Nothing was done on those days anyway. That is so true. I got like 2 to 3 hours, no, mostly 2 hours of work done. And that was mostly in the morning before people started showing up. Mostly before Justin showed up. Let's see. All right, so that, according to this, with the player and enemies ready, in the next part, we'll bring them together in a new scene. We'll make enemies spawn randomly around the game board and move forward, turning our project into a playable game. All right. Next, the main game scene. So we got our mob and we have our players. There's our player and there's our mob. Now it's time to bring Everything together we did together. Sorry. Now it's time to bring everything we did together into a playable game scene. Create a new scene and add a node named main. The reason we are using node instead of a node 2D is because this node will be a container for handling game logic. It does not require 2D functionality itself. Click the instance button represented by a chain link icon and select your saved player file. All right, so scene, new scene, and we want just a node. So create a node, name it main. Okay. Then we're going to add the player to it. And there's my player in my scene. When do we get more feet? Behave yourself. Like, subscribe, donate. Once I get my Patreon, all the feet will be on Patreon. No, there won't be. Let's see. Now add the following nodes as children of main and name them as shown. Add all Greg's for his OF channel. Dude, I really need a chatbot to read this stuff for me. Hashtag only feed games. You know what? If this is decently easy to make, I might. I was thinking in Star Wars Return of the Jedi. No. Which one was it? Anyway, Luke firing the missile thing where it's zooming in. It's like I might just make the game just do that, where it's just zooming in like that, and you have to press the button at the right time to fire the missile to see whether or not you can blow up the Death Star. But I won't call it a Death Star. It'll be not Death. Kill Star? Yeah, Kill Star. Something like that. Don't want to get sued by Disney. All right, sorry. Yeah, I'm getting distracted. You guys distract me. I love it. Let's see. Now we need to add. What was it? Bird box, where the enemies were invisible and you could only see their feet prints. Oh, that would be cool. All right, so we need to add a timer. Create. I'm actually just going to do this. Let's copy it and paste and paste. And let's add another one. Marker 2D. Okay. Now let's rename these to what it's told me to. Mob timer. This will be the score timer. And then this will be the start timer. And this will be the start position. Well, Craig, I'm trying out that TTS tool. See, not a perv. Try it out. It works. What TTS tool? All right. Set the wait time property of each of the timer nodes as the following values. All right. Mob timer, inspector, wait timer 2.5. Score timer is at 1. Start timer starts at 2. In addition, set the one-shot property of start timer to on and set position of the start position to 240. Wait, where is it? Start position. Transform position to 240 by 450. Right, so that's the starting position. Oh no, Greg is a get more viewers bot. If only. Oh, text to speech tool. God, sorry, I'm being a bit slow today. Man, I can't believe this tutorial is taking me like 2 hours to do. I feel so lame. All right, the main node will be spawning new mobs, and we want them to appear at a random location on the edge of the screen. Add a Path2D node named Mob Path as a child of main. When you select Path2D, you will see some new buttons in the top of the editor. All right, Path2D. Ooh, there we go. The got automod TTS does not equal titties. Okay. All right, so this is going to be mob path. All right, so these are the new options. Select the middle one, add point, and draw the path by clicking to add points at the corners shown. To have the points snap to the grid, make sure use grid snap and use smart snap are both selected. These options can be found to the left of the lock button, appearing as a magnet next to some dots and intersecting lines respectively. How was the initial setup of Godot? Take very long? No. So I got it set up last night, and it's literally just a zip that you download and open, and the executable's just right there, ready to run. Very, very small, actually. Completely 100% self-contained. Really, really simple to use. So, yeah, I was up and running and I actually went through the introduction and the step-by-step part of the documentation, and it's definitely geared toward new developers. So you can kind of skim through a lot of it. But it's not terrible. Okay, so select the middle button, add point. Okay. And draw the path by clicking to add points at the corners shown. To have the points snap to the grid, make sure use grid snap and use smart snap are both selected. Use smart snap, use grid snap. Okay, so there to there to there. Oh, nope. 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 No. Remove. Add. Okay. There. And back to here. Just making sure. Draw the path in clockwise, or your mobs will spawn pointing outwards instead of inwards. Okay. What's this button? Close curve. Close curve. 1, 2, 3. Okay. That's all right. I'm gonna try this again, just so I can see how it works. So we go zoom in. We go here. We go here, and here. Then we hit this button and it connects the last one too. Okay. That's kind of cool. After placing the fourth button, click the close curve button and your curve will be complete. Now that the path is defined, add a path follow 2D node as a child of path mob. Name it map spawn location. All right. Path, excuse me. Follow 2D. And we're going to name this, what did it say? Mob spawn location. This node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. Oh, so now I understand. So this is going to slowly move along this actual path along the edge of my screen, which I could technically go off the screen if I wanted to. And we'll end up creating code that says at random times create a mob and then start moving in a specific direction and then just keep moving that direction. Okay. Okay, here's the main script. Add a script to main. At the top of the script, we use export var mob scene packed scene to allow us to choose the mob scene we want to instance. Okay, so we add the script. Now we're in the script tab. So I'm just going to go ahead and steal this. I don't want to type it out. Being lazy now. Sorry. Okay, export var mob scene packed scene. I wish it would tooltip within the script. But here, if you notice, here's a mob scene. New pack scene, okay? Click the main node, and you will see mob scene property in the inspector under main.gd. Yep. You can assign this property's value in two ways. Drag mob tsn tscn from the file system doc and drop it into the mob scene, or click the drop down and select load. So we want to do that. Open. All right, so there's that. Next, select the instance of the player scene under main. Right here. Scene doc. And access the node doc on the sidebar. Make sure to have the signals tab selected in the node doc. Signals. You should see a list of signals for the player node. Find and double click the hit signal in the list, or right clicked. Okay, connect a signal to a method. This will open the signal connection dialog. We want to make a new function called named game over, which will handle what needs to happen when a game ends. Type game over in the receiver method box. Okay. Game over, which will handle what needs to happen when a game ends. Type game over in the receiver box at the bottom of the signal connection dialog and click connect. You are aiming to have the hit signal emitted from player and handled in the main script. Add the following code to the new function as well as a new game function that will set everything up for a new game. Okay. Let's go ahead and also do that. Function new game. Wait. So score is going to equal 0. Since we have a start function in player, start position dot position. We start the timer over. Right? Did I forget something? Why is it mad at me? Oh, because I did that. Okay, there we go. So start timer. Start timer doesn't have a script for start. So that's just starting the timer. Right? Oh, when you start a new game, it starts the timer, obviously. Wow, I am not bright. And then it's calls the start player, which unhides the player and sets the position at that start position location. Resets score to 0. Okay. So now here for game over, we are. So score timer, we have to stop it. Mob timer. That stop. Why don't we stop the start timer? Why would the start timer not have a stop anywhere? Okay. Now connect the timeout signal of each of the timer nodes, start timer, score timer, and mob timer, to the main script. Start timer will start the other two timers. Score timer will increment the score by 1. Okay, so let's try this again. So start timer. Node signal timeout. We want to connect that to main. Score timer. I'm going to connect the timeout to main. And mob timer. We want to connect the timeout to main. Now connect the timeout signal of each timer node, all 3 of those, to the main script. Okay. Start timer will start the other 2 timers. Start timer. Okay. So the mob timer and score timer start here. Is there any testing validation as you go? Yeah, at any time. So I'm gonna go ahead and save it. There's a debug mode. So for instance, let me give you an example. So here is the player, my player scene. Let me go to my 2D. So this is my player scene, and it has a script attached to it. So when I hit F6, it'll generate it. Why didn't it run it? F5. Player. Open. Why is it not visible? Okay. Well, it was working earlier. um, but yeah, it's like it creates a window so you can debug it and test out specific things. Live coding at its finest. Absolutely. I have no idea why that just happened. Errors. Parameter body is never used in the function on body editor. Oh, it might be airing out. Um, worked on my machine. Thanks, O'Griggs. It might be airing out because I have like an error somewhere else. Unused parameter. Player GD. In the script. There's an unused parameter. Oh, right here? Body? $44. Yeah, I have an unused body. That's an error? Can I remove it? You need to close those parents. Line 48. It's just a. I did. The error I'm getting is that I didn't use body right here. So let's say I do this. Now let's try it. F6. Nope, not working. Hmm. Never used. If this is intended, prefix it with underscore body. Okay. There. Okay. Layer TSN. Weird. Why is it not showing up now? It was working earlier. Suck up. Oh, I know. This. I have it on hide. That's why. There. Sorry, F6. That's what was going on. So yeah, there is a way to debug individually as you keep going. So as you create a scene, you can run F5 or F6 against that specific scene to make sure it shows up or it's moving as you expect it to, with inputs and whatever. Fix one bug, pass it around. 135 bugs on the wall. I like the song. I like the meme about it. I also hate it. There's too much truth to it. So yeah, there is. You can test as you go, which is really nice. I got to get back to script main. This is where I'm at. So on score timer timeout, we're gonna do score plus equals 1. All right, on mob timer timeout, we will create a mob instance, pick a random starting location along path 2D, and set the mob in motion. The path follow 2D node will automatically rotate as it follows the path. So we will use it to select the mob's direction as well as its position. When we spawn a mob, we'll pick a random value between 150 and 250 for how fast each mob will move. It will be boring if they were all moving at the same speed. Note that a new instance must be added to the scene using add child. So on mob timer, okay. So var mob is to mob scene instantiate. Okay. So we're instantiating an actual mob, which is one of these buddies right here. And then we need to get the mob location. So are these all methods provided by Godot? No, a lot of them are. So the ones that are underscored are functions that are already there, yeah, provided by Godot. So underscore ready is on instantiation. Underscore process is what happens every single frame. And then these underscore on something are related to signals. So this game over and new game, these are functions that I create, um, or I have created so that I can use them when, for instance, a signal occurs. So if a timer pops, or let's say a user clicks a button, then I can call one of these functions. Can you make the main character a sky panda? I don't think Sky Panda would like me to do that. I might do that one off stream. Mob spawn location is equal to. All right, so money sign, mob path, mob spawn location. All right, so that says get the node's mob path of the scene main. So this right here, this mob path, which on the 2D is somewhere along here. And then we're going to divide it by the mob spawn location, which is somewhere along that path. Now, mob spawn location. I don't know what this progress ratio does. And F. We're just getting a random value for the progress ratio. Choose a random location on path 2D. Okay. Create a new instance of mob scene. Yeah. Okay. Next, we want to set the mob's direction perpendicular to the path. All right. Var direction. Spawn location. Rotation. Plus pi. I like that you can just call pi. That's nice. Divided by 2. Math. All right, so then we set the actual position. Spawn location dot position. Now add some randomness to the direction. A random float in a range of negative pi divided by 4 and pi divided by 4. Okay. So then we're going to rotate in that direction. All right. And then we're going to pick a random velocity between, let's see, this is a 2 vector. Random float in a range between 150 and 250 and 0, 0. Something. Oh, I put a period instead of a comma. Okay. All right, and then now linear velocity rotated direction. Okay, so now we're setting the actual property on the mob for linear direction. And then we call the actual add child. So the spawn, so the instantiated mob then actually shows up within the scene itself. Oh, sorry. Important. So this is explaining the math. Y pi in functions requiring angles, Godot uses radians, not degrees. Pi represents a half turn in radians, about 3.1415. There is also tau, which is equal to 2 times pi if you're more comfortable working with degrees. You'll need to use the deg to rad or rad to deg function to convert between the two. Now we test the scene. Okay. So ready, we just call new game. Let's also assign main as our main scene, the one that runs automatically when the game launches. Press the play button and select main when prompted. That bot showed up again. Can always count on that bot showing up. Project. Okay. All right. So we want to do 6. Hmm. Who are they, Greg? How do I set the scene? Scene, debug, editor, help. Hmm. Run current scene, run specific scene, run project. Why is that not highlighted? Current scene? I won't snitch on my own kind. Show me the rebel leaders. Uh, oh, wait, I need to go back to the script and unhide that. Set as main scene. Okay, there we go. So F5. No, not F5. F6. If you had already set another scene, okay, so you should be able to move the player around, see mobs spawning. Press the play button, select the main screen when prompted. You should be able to move the player around, see mobs spawning, and see the player disappear when hit by the mob. When you're sure everything is working, remove the call to new game from ready and replace it with pass. What's our game lacking? Okay, so this isn't. Okay. Yeah. Wait a minute. Something's not working. So the main scene calls new game. Player start position. Okay. What is going on here? Why isn't it running? To script main. Ready. Call the new game. New game's right here. Player dot start. There's nothing. Did I not save everything? Missing. That's the mob timer. which will spawn the mob. Not running process. Start. There. Start. Position equals pause. We show. Then we don't. We disable. What's going on? Run project. Okay. All right. Invalid assignment of property or key position with value of type vector 2. Rigid body to mob. Okay. So we got an error when it attempted to set that. Okay. Oh. Me mistyping stuff everywhere? Yes. Debugging. Invalid assignment. Mob type. All right, so let's go back up. Okay, mob spawn location dot position. Mob dot position. Okay, why is that incorrect and failing? Rigid body 2. Hmm. Is that a not? Is that not giving me a vector 2? Okay, let's just do this and see if it's something I did. Yep, it's something I did. What did I screw up? Okay, mob equals mob scene instantiate var mob spawn location. Spawn location. Spawn location dot progress ratio rand f. Okay. Direction mob spawn underscore location rotation plus pi divided by 2. Session equals spawn underscore location dot position. Oh, I misspelled position. That's what it is. Two errors. Do that. Do that for now. So I can get rid of my errors. Okay, there we go. Now it's working. Hey, buddy. Hey, I got you. I got you. And I'm dead. Okay. All right, so we got most of the game working now. So they want me to go to main. Since I'm already past I'm streaming. I think I want to just finish this game since we're almost there. Ship it. All right, next. Let's get the HUD. We're almost done. Almost done with this first tutorial. Next week we will try out the 3D. Maybe it'll go faster. Who knows? Probably not. Doesn't help that I'm reading literally everything. The final piece of our game needs a user interface to display things like score, a game over message, and restart button. Create a new scene. Click the other node button and add a canvas. All right, I'm just going to clear this out for now. So we have a new scene. We need a canvas layer right here. We're going to name this HUD. Do you guys care if I read literally everything, or do you want me to kind of like skim and go? The canvas layer node lets us draw our UI elements on a layer above the rest of the game so that the information is displayed isn't covered up by any game elements. HUD needs to display the following information: score, changed by the score timer, a message such as game over or get ready, a start button to begin the game. The basic node for UI elements is control. To create our UI, we use two types of control nodes, label and button. Create the following as children of HUD: two labels, a button, and a timer. Okay. So label, then copy, and then we'll paste that. And then we'll get a button. And then we will add a timer. If it fails QA, well, we'll obviously need to send it back for you to peer review and get leadership approval. Don't forget, we need like 6 meetings in order to do all that. Score label. Message. Start button. And message timer. All right, click on the score label. Under the text, type a number into the text field in the inspector, and default font for the control nodes is small and doesn't scale well. This is a font file included in the game assets called, I'm not going to read that. To use this font, do the following. Under theme override fonts, choose load. Text overrun. All right, under theme overrides. Where the is that under controls? Yeah. Theme overrides. Fonts empty. Load. There we go. Open. Oh yeah, I can never forget the Agile Scrum meeting to follow the waterfall meeting before you need a meeting to explain it to your project manager, who will then invite you to the leadership meeting so you can explain it again because they don't know how to explain it. And don't forget your one-on-one about how you are failing to, failing to meet deadlines. Okay, and then we want the font size. Theme overrides font size to be 64. Okay, font size is too small. Theme overrides font size. Once you've done that with the score label, repeat the changes for message and start button. Message. Got you. 64. And start button. Font size 64. Okay. All that's done. Control nodes have a position and size, but they also have anchors. Anchors define the origin The reference point for the edge of the node. Arrange the nodes as shown below. You can drag the nodes to place them manually, or for more precise placement, use anchor presets. All right, so score label is going to get anchored. So we're going to use that anchor point right there in the center. Score label. Set the horizontal alignment and vertical alignment to center. 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 Center top. Okay. Message. Dodge the creeps. Okay. Horizontal. Okay, we want this to be center and center. Set the auto wrap mode to word. Under control layout transform, set size X. Wait, control layout transform. We want size X to be 480. Choose the anchor preset center. Anchor preset center. Okay. Now the start button obviously is going to say start. And same thing, layout, transform, size 200 to make it a little wider, size 100. Anchor preset, center bottom. Okay. Under control layout, transform position Y. We want that 580, just a little from the bottom. And on the message timer, set the wait time to 2 seconds and set the one shot to 1. Add a script to the HUD. Okay. Signal start game. Okay. We now want to display. All right, let's just copy. All right, so we're going to do that. So the message is going to get the text is equal to text, show it, and start the message timer, which is going to be, 2 seconds. We also need to process what happens when the player loses. The code below will show game over for 2 seconds, then return the title screen after a brief pause. Show the start button. Okay. So show message, we'll pass that in, and that's what will happen. Await for the timeout, which is 2 seconds. Message, dodge the creep, goes back. Message shows. Await get tree, create timer, make a one-shot timer and wait for it. Start button dot show. Okay, this part's a little weird for me. This function is called when the player loses. It will show game over for 2 seconds, then return to the screen after a brief pause, show the start button. When you need to pause for a brief time, an alternative to using a timer node is to use the screen tree's create timer. This can be very useful to add delays, such as in the above code, where we want to wait some time before showing the start button. Add the code below to HUD to update the score. Okay. So update score gets passed in. All right, connect the pressed signal from the start button and the timeout signal from the message timer. So start signal pressed. Connect that to HUD. And then we want to add the timeout for message. Connect to HUD. Let's just go ahead and do that. So the start button, we're going to hide it. And then the start button is pressed. And we're also going to do a start game.emit. Where's start game? Signal start game. It doesn't really explain the signal right here. Darkest Levity. Hey, welcome, Darkest. Gregs, what are your first impressions of Godot? Um, as most game engines, it's not super intuitive, but I think structurally, it's not bad. It seems pretty straightforward for the most part. I'm sure there are some complicated stuff that you can do with this, and it just takes time to learn. But I think for the most part, it's not bad. It's like art assets, fonts, you just drop right in. The inspection and properties of each of the elements are very simple. It doesn't feel super overwhelming. So I think I can get used to this pretty easily. It is using an MIT license, so you can't sell any games that you build with it. It's got to be all free, but that doesn't stop you from adding ads to it. Free games with ads. All right, where am I at? So that we did that. So now we're connecting the HUD to the actual main. So let's go back to main. Darkest, you know what would be a fun community project? Create a simple game design doc and have everyone who wants to participate build the same game in an engine of their choice and compare the outcomes. Time constrained, of course. Yeah, that'd be kind of cool. No extra credit though for adding extra features. Like this 2D game is like I wouldn't mind seeing you try to build this in Unreal. Since I mean this is a very straightforward doc. Pirate software does that sometimes and usually works out well. I don't know pirate software. Let's see. Hold up. In the no tab. All right, we need to go back to main. Main script. Right here. And then we need to connect the HUD functionality. Oh, we need to go back to the scene main. And we need to add the HUD as a child. And then we need to go and within this scene, the script. Okay. Unreal does have 2D support. Yep. Great way to get new game devs to try things out. I used to build games in Coco's 2DX a lot. I think there was a Love 2D or something like that I was taking classes for, but wasn't able to finish it. Okay, in main. Here, this one. Inspector in the node. Connect the HUD's start game. So this one, NUD. Start game. In the Node tab, connect the HUD's node. Oh, there it is. To the new game function of the main node by clicking the pick button. Pick button in the connect to signal window. Pick new game. Oh, okay. So that's how that works. Now it has a whole GUI. I built my first 4 iOS games in Coco's 2D in the Glue engagement test web game. That's a bad word. We don't say that word in my stream. Okay, then we hit connect. All right, so here's that signal indicator. So now we specifically said that this signal from here is going to call this function in main. Receiver method window. Verify the green connection icon. Yep. So then we do this. Grab this. And let's go ahead and do this. Um, I guess my bad. In game over, we want to add this. Okay. Finally, add this to the on-score timer timeout. On-score timer timeout. Right, we need to update the HUD. Remember to remove the call to new game from underscore ready. Okay, we did. If you haven't already. Otherwise, your game will start automatically. All right. So this way, the HUD is owning starting and stopping the game. The main does not do anything. It handles the actual game logic of the scene the container of the main scene. Okay. So that's how it's adding. Removing old creeps. If you play until game over and then start a new game right away, the creeps from the previous game may still be on the screen. It would be better if they all disappeared at the start of a new game. We just need a way to tell all the mobs to remove themselves. We can do this with the group feature. In the mob scene, so that's this one right here. So does this engine separate logic and draw loop? Yes, in a way. So let's go. Where is it? Is it here? There's a right. So this is. I mentioned this at the beginning of my stream, but this is really interesting. They said, we recommend dismissing architectural code patterns when making games with Godot, such as model view controller and entity relationship diagrams. Instead, you can start by imagining the elements players will see in your game and structure your code around them. So essentially, it's like, I like this example better because it kind of makes sense in my head. This is an example of what a scene diagram would be for an open world game. You have the main terrain, and then within the terrain you have a citadel. Within the citadel you have houses and a church. Within the house you have a room and doors. Within a room you have a table and chairs, and then on a table you have a vase. And then a church has seats. Also within a terrain, you have bridges, guards, and then a terrain will have a player and a HUD. Arrows indicate what is owned by what. So a citadel owns churches and houses, and a church owns seats. And then from here, The way that you would do this is that you would create a scene, which is a room, and then you would instantiate that, but you could create different types of scenes. They do a lot with inheritance, basically. So that way, these are all self-contained scenes. So the way they describe it is everything is basically a scene. So here, let me open up the player scene. So this is a player scene, and the smallest individual piece is a node. Not quite what I was asking, but element hierarchy is cool. Sorry. Yeah, I didn't quite understand the full question, I guess. So, the logic itself stays within this specific scene, all within the player. Same thing within the mob. And then each node itself has signals that are predetermined, or you could create your own signals. And then what you do is when you want them connected, you just grab it and say, hey, I'm going to connect, for instance, this player when I have a hit signal that I created within the script of a player. Where is it? Hit. Oh wait, there's the player one. On hit. Signal hit. So this defines a actual hit signal. And then from there, that says that this is going to emit a hit signal. And then from there, I can go somewhere else and say, this is going to be a receiver method for that signal. So it does kind of like break it up like that a little bit, separating the logic. I mean, I could create one script that just has everything, but the way they do it is that each individual node has, you can control each individual node specifically. I forgot where I was at. Contents, heads up display, moving old creeps. Okay. In the mob scene. We're in the mob scene. Sorry, message-based comms is great for games. Yeah. This way it makes it really, really simple. It does remind me of the way that Unreal does it too. We just need a way to tell all the mobs next. So mob scene, which is, am I in the right mob scene? Mob scene. Inspector. That's mob timer. Mob scene. Mob node signals. Okay. Next to signals, click groups. This is it. And you can type a new group and click add. What? I don't see no manage groups. Is that it? Yes, that's how that works. Maybe they didn't update the image yet. Click the node tab, inspect to the same place where you find the node signals. Next to signals, click groups. Wait, maybe I was in the wrong place. Node tab. All right. Node. Node tab next to inspector. Next to signals, click groups, and you can type a new group name and click add, which I just did. Now all mobs will be in the group's mob. We can add the following line to the new game function in main. which is here. New game. Get tree all group mobs queue free. The call group function calls the named function on every node in a group. In this case, we are telling every mob to delete itself. The game's mostly done at this point, and the last part will polish it by adding background looping music and some keyboard shortcuts. Oh, maybe I should just end it right here. We're almost an hour extra. Now completed all the functionality for game. Okay, let's go ahead and take this for a test run. Oh, here we go. 6. So you click this. Get ready. Oop. Okay. I want to make sure, try and get more creeps on the screen. Okay, it does delete them all. Okay, cool. All right, let's add a bit more juice to improve the game experience. Feel free to expand the gameplay with your own ideas. Default gray background is not very appealing, so let's change the color. One way to do this is use color react node. Make it the very first node under main. All right, so color react. So move that up. We're going to put that right there. So that it will be drawn behind the other nodes. Okay, so it is a hierarchy. Only has one property, color. Choose a color you like and select layout, anchors preset full. Layout. Anchors preset full. All right. You know me in purple. Love me that purple. There we go. Let's go with that. You could also add a background image if you have one by using texture rect node instead. Okay. Sound effects. Sound and music can be the single most effective way to add appeal to the game experience. In your game's art folder, you have 2 sound files: House in a Forest Loop for background music and Game Over for when the player loses. Add 2 audio stream player nodes as children of main. Okay, audio stream player 2D. Okay, let's copy that, paste it. Name one of them music. Okay, music. And the other death sounds. On each one, click on the stream property and select load. Stream property, load. Then art. Yeah, there it is. Open. And this one, death sound, load. No, game over. All audio is automatically imported with the loop setting disabled. If you want the music to loop seamlessly, click the stream file arrow, select make unique, and then click on the stream file and check the loop box. To play the music, add that. Okay. All audio is automatically imported with the loop setting disabled. Right here. If If you want to loop seamlessly, click on the stream file arrow, select Make Unique. No, that might be old. If you want the music to loop seamlessly, then click on this, check the loop box. Make unique. And then that. Oh, okay. There we go. To play the music, we're going to add that to the new game. All right, so we go to on new game. To music dot play. Then on game over, music dot stop, which makes sense, and death sound dot play. All right, keyboard shortcuts. Since the game is played with keyboard controls, enter to, oh, okay. Project settings. Let's add a new action. Start. Button. Add. And then we're going to do enter. Okay. What's that? Oh, they want to call it start game. Whatever. Start game. In the HUD. Is it in the script? Or in the scene? Inspector. Node, signals, history. No. In the HUD scene. Right? Find its shortcut property. Shortcut property. In the inspector. Start button. Control. Shortcut right here. Empty. New shortcut? No. No, that's not right. Let's go back. Load. No. Create a new shortcut. Okay, it is create a new shortcut. Clicking within the box opens the events. Array input, add element. Input. See, size. Add. No, don't want to do that. Input event key. Event action. And within here, action is start game. Huh? So that's that. All right, let's give it a try. F6. Enter. Nope, that didn't work. Supposed to. What? Okay. I did something wrong. Okay, select project, start game, and add a key mapping for the enter key. Yep. Now would be a good time to add controller support if you want to use one. Nope, not going to. In the HUD scene, select the start button. All right. And find a shortcut property. I did. Create a new shortcut resource. Yep. Open the events array and add a new array element to be clicked on. Right. Array input element. Add element. Input event action. Input event action. And name it start game. Start game. Now, when the start button appears, you can either click it or press enter to start the game. Okay, so that didn't actually work. Action this event corresponds to. From events defined for this action in the input map. If -1, unique ID will be used. Actions pressed with this ID will need to be released with another event action. That must be new. Enter. Enter. Okay, so the signal's not happening. Don't think this is working. Shortcut does not appear to be working. Right? Project settings. Start game. Enter. That. Oh, okay. It didn't actually reset. Let's do that again. Click the input event tab. Okay. It didn't render or compile properly. It's like it was still using the old stuff. So, all right. So that is the first tutorial in Godot. Creating a 2D game, very simple. Generous hitboxes. Oh, I defined the hitboxes. So if I do it again, that's cool. Oh no, it went back. F5. Okay. See? Boop. Okay. So, it's pretty straightforward. It wasn't that bad. I think very simple game, kind of like a mobile shooter game, would be pretty simple on this with 2D assets, make little on the pixel side. Very simple, straightforward. We could definitely do something like that. I would definitely want to play around with this a little bit more. And so if you guys want, we'll continue down the Godot tutorials for next week as well. And we'll just keep doing Coding Fridays. and see how much more we can learn with this and try to get a little bit further with the Godot language. And maybe in the future, if we don't want to do Godot anymore, we'll just transition to a different language and try a different game. And then maybe Darkest Liberty, if you have time and want to take off work, we can do some collaboration during this time. Do a collab for building a different type of game or something else, and something very simple. So, all right. So that's going to be my stream for today. Thank you so much for stopping by and listening to me kind of basically read through the Godot docs and tutorials and watch me create this game. I really appreciate it. Thanks for stopping by, and I hope to see you next week. So